A satellite is revolving around Earth in a circular orbit with kinetic energy x. The time period of the satellite is proportional to. The answer is kinetic energy is inversely proportional to radius, and time period is directly proportional to r to the power 3 by 2. Therefore, time period is directly proportional to kinetic energy to the power minus 3 by 2. Therefore, option C is correct. Next, a battery of EMF E has an internal resistance R. A finite variable resistance R is connected to the terminals of the battery. A current I is drawn from the battery. V is the terminal potential difference. If R alone is gradually reduced to 0, which of the following is best describes I and V? The answer is the current drawn from the battery is I is equal to E upon capital R plus small r. Terminal potential difference V is equal to IR. When R is reduced to 0, I is equal to E by small r, where R becomes 0, potential also becomes 0. Therefore, the correct answer is 2. I approaches E by small r, V approaches 0. Next question. The velocity of a body moving in a vertical circle is of radius r is under root g by under root 7 gr at the lowest point of the circle. What is the ratio of maximum and minimum tension? The tension is maximum at the lowest point and minimum at the highest point. Tension at the lowest level is mg plus mv square by r, which is mg plus 7 mgr by r, which is 8 mg. And tension at the highest point is mv square by r minus mg, which comes out to be 2 mg, and therefore the ratio of T max upon T minimum is 4:1. Next, question number 12. The power of convex lens is 2 diopters. Its power is to be reduced to 1.5 diopters by putting another lens in a combination with it. What is the purpose? Which of the following lenses will serve this purpose? So as we know that power is equal to P1 plus P2. Here P1 is equal to 2 diopters, P2 is equal to 1.5 diopters. Therefore 1.5 is equal to 2 plus P2, which is P2 is equal to 1.5 minus 2, which is minus 0.5 diopters. Negative sign shows that P2 is a concave lens. As focal length is equal to 1 upon power, therefore 1 upon minus 0.5 is 2 meters. Therefore the correct answer is 1, a concave lens of focal length 2 meters. Next is the most frequently asked question. In the circuit given, current through the Zener diode is. So we can see that the voltage drop across R2 is equal to the voltage drop across V Zener, which is 10 volt. Current through R2 is V equal to IR, therefore I is 10 upon 1500 ohm, which is 0.667 into 10 to the power minus 2 ampere. Next, the voltage across R1 is VR1 is equal to 15 minus VR2. VR1 is equal to 15 minus VR2. Therefore VR2 is 10 ohms. Therefore it comes out to be 5 ohms. Across voltage across VR1 is 5 ohms, 5 volt. Next, current through R1 is 10 into 10 to the power minus 3 ampere, which is 10 milliampere. Therefore current through Zener diode is 10 minus 6.67 milliampere, which is 3.33 milliamperes. Next option, then answer is fourth. Next question. In the given circuit, voltmeter and electric cell are ideal. The reading of the voltmeter is. The current to the ideal voltmeter is 0 according to the loop rule. E minus 1 into I minus 1 into I is equal to 0. Through the equation we can make from the loop rule. Therefore E comes out to be 1. Therefore I comes out to be 1 ampere. Reading of the voltmeter VA minus VB is. Reading of the voltmeter is VA minus VB, which comes out to be 1 volt.